Hello and howdy, my fellow mathletes. We're looking at question number 4 in this video on the 2017 Euclid contest. I would like to note, just for a moment, you can get a copy of this contest by clicking the very first link in the description. Try the contest out, and we're only at question 4. The harder questions are yet to come. See what you can make of them before watching those future videos. I cannot overemphasize how important it is for you guys to practice on your own rather than just watch videos. You don't really learn a whole lot watching someone do solutions. You just sort of say, yep, oh, I would have done that. Yep, oh, you could have done that calculation faster. But if you actually go out and try, you say, I don't remember this result, or, gee, I'm really stuck as to how to get this angle. And then later, you say, wow, I couldn't get that angle. I should brush up on angle results. I should brush up on on circle theorems, things like that. That's how you learn what you need to do, okay? That's the best way to practice, is to get better, is to practice. Practice and identify your weaknesses. Anyway, that's enough of a PSA. Question number 4. We've got 2 parts, a light bulb and a written part. A, the equations y equals a x minus 2x plus 4 and y equals 2x minus h squared plus k represent the same parabola. What are the values of a, h, and k? Okay. So, one of these parabolas is written in root form. And the other one is written in vertex form. Okay. So if you're very quick at these things, just double check that I copied them down correctly. Yep. If you're very quick at these things, you will be able to say, A will be 2, because vertex form looks like this. So you say, A is 2. Okay. It's a light bulb, remember? So if we should go quickly. H is the low point of the vertex, and that is halfway between the roots. The roots here are 2 and negative 4. So halfway between that, 2 plus negative 4 is negative 2, so negative 1. So H will be negative 1. Plug in negative 1 in here. 2, negative 1 minus 2, negative 1 plus 4. And you'll get negative 3 times 2. So that'll be negative 18. K will be negative 18. Okay, good, done, very quick. All right, that's fine. Let's see how we would do it a little more slowly. You know, we don't understand all the properties of parabolas. But these are nice properties to know, is that the A is always the coefficient up front. And, the H, the vertex, is always halfway between the roots. These are important things to know. And they allow us to do things like question 4 really quickly, but let's do it a little slower. So one of the nice things about parabolas and lines and cubics is that they can be expressed with polynomials. So what we're going to do first is we're going to expand this out. So x squared plus 2x minus 8. And then 2, it'll be x squared minus 2xh plus h squared plus k. And one of the nice things about polynomials is that if we compare coefficients of the same power of x, we must have the same coefficients. Okay? There's only a unique way to write a polynomial. There's only one way to write a polynomial. So since they're both polynomials, therefore I get a series of equations. So I get, comparing my x squared terms, I can see a is 2. Well, that wasn't so bad, but we already jumped to that conclusion a while ago. But we can also see 2a is going to be negative 4h. Okay? And finally, comparing our constant terms, we get negative 8a is 2h squared plus k. Okay, well, a is 2. That's fine. Plug that into this next equation, we get 4 is negative 4h. And I don't have to tell you there that h is negative 1. Now plugging both of those into this equation, negative 16 is 2 times negative 1 squared plus k. This is 2, bring it over to the other side, negative 18 is k. So there's a slower, more polynomial-based approach to the question, but if you want to just do it rapidly, knowing parabola facts, that's fine too. It's a light bulb question, we're just looking for these 3 answers. Okay? Now what you can't do is speed through 4b, because 4b is written. So we actually have to write our solutions, justify things. So what does b say? In an arithmetic sequence with 5 terms, the sum of the squares of the first 3 terms equals the sum of the squares of the last 2 terms. If the first term is 5, determine all possible values of the 5th term. And just a nice little reminder here, an arithmetic sequence is a sequence in which each term after the first is obtained from the previous term by adding a constant. And they give us a nice little example. Now, in general, the constant that every pair of successive terms differs by is called the common difference. So I might start off by saying let D be the common difference. Now, in general, an arithmetic sequence looks like this, where A is your first term. But they told us the first term, so our sequence looks like 5, 5 plus D, 5 plus 2D, 5 plus 3D, 5 plus 4D. Okay? To get a different sequence, we switch up the D value, but they gave us something special for this arithmetic sequence. The sum of the squares of the first 3 terms equals the sum of the squares of the last 2 terms, and all we really care about is the possible values of that last term, the 5th term. But we can set up an equation with this extra information. 5 squared plus 5 plus D squared plus 5 plus 2D squared is equal to 5 plus 3D squared plus 5 plus 4D squared. So we use FOIL, expand things out, and we'll get 25 plus 10D plus D squared plus 25 plus 2 times 2 is 4 times 5 is 20, 20D plus D squared. And then we get 25 plus 30D plus 9D squared. Oh, this one should be 4D squared, shouldn't it? So plus 9D squared. Plus 25 plus 2 times 20, so 40D plus 16D squared. Okay. So what can we do? Well, we can cancel some things. 25 here, 25 there, 2 25s there. And we can collect some like terms. So we're left with just a single 25 over here, 30Ds here, and 5D squareds. Over here we've got 70Ds and 25D squareds. Well, let's bring it all over to one side. So we'll say 0 is equal to negative 25 plus 40D plus 20D squared. I'll divide that by 5, simplify things a little bit, so 4D squared plus 8D minus 5. And now we've got a quadratic equation. Now we could try and factor it. I'm always wary to do that when we have a non-unit constant up front, but you can certainly try that. I'm just going to fall back on the quadratic formula because it always works. So we'll get 2 possible values for D, it looks like. So negative B plus or minus the square root of B squared minus 4AC all over 2A. That'll be negative 8 plus or minus square root of 64. The 2 negative signs will become a plus. That'll be 16 times 5, which is 80. All over 8. Now we can't take out a factor of 64 everywhere, but we can take out a factor of 2. Or sorry, a factor of 4, so we can bring out a 4 as a 2. It becomes 16 plus 20, which is 36. Well, that's not bad. Negative 8 plus or minus 2, so this becomes 36, but then the square root becomes 6. So negative 8 plus or minus 12 all over 8. Okay, and so that's going to be negative 8 plus 12 is 4, so 4 over 8, or negative 8 minus 12 is negative 20. Negative 20 over 8 is our other one. We can simplify. D is 1/2. Or top and bottom divides by 4. So we can, negative 5 over 2. So these are our possible D values. But for each D value, we're going to get a different fifth term. So the fifth term is 5 plus 4D. So it's going to be 5 plus 4 times 1/2, or 5 plus 4 times negative 5 over 2. So 4 times 1/2 is just 2, so it's either going to be 7, or 4 over 2 is 2, so 10 minus, so 5 minus 10 is going to be negative 5. Okay, and we can check that really. If we wanted to, we could get these sequences. We could do 5, 5.5, 6, 6.5. We weren't asked for these sequences, but we can write them down. And the other one is going to be 5, 5 over 2, 0, negative 5 over 2, negative 5. Now this one, it's really clear because the 0 in the middle doesn't do anything, that the sum of the squares of the first 3 is the sum of the squares of the last 2. But I might, just because I feel like it, check with my calculator that the sum of the squares in the first sequence, the 5, 5.56, 6.57, really does equal the sum of the squares of the last 2, just to verify for myself. Now, if I thought I had a shot at getting all the way to 10, I probably wouldn't. I'm fairly confident in my quadratic formula and everything like that. But if it's my first Euclid, or I'm in grade 8 or something like that, doing question 4 completely is pretty darn good. The average on these contests is somewhere between 40 and 50. So being able to do the first 4 questions, get 10 out of 10 on each of them, is pretty good for a first time, even for a second time. Let's just stop and check. So 5 squared, 25, plus 5.5 squared, plus 6 squared is 91.25. I'll minus 6.5 squared, and minus 7 squared, and I do get back down to 0. So it really did all work out. Okay, so we get 2 sequences, 2 fifth terms, and remember, we care about the fifth term. That's the thing that they asked for. So these are our answers, not the actual sequences. 5 and negative 5 are what we're looking for. Okay, that wraps up question 4. Join me in the next video as we take a look at our next question, question number 5.